Have you ever stared at a 3-mark maths question and thought, where do those marks actually come from? Well, today we are going to crack that code. We're taking just one GCSE question, and we are going to dissect it, not just to get the answer, but to learn how to think like an examiner and make sure we get every single point.
Okay, first things first. See this little symbol here? This tells us the question is from a non-calculator paper. And that, right there, is a massive clue. It means every single step of your thinking, every little calculation, has to be written down clearly. You can't just punch it into a machine. Your working is literally where the marks are. So here's the mission. We've got this classic coordinate geometry question worth a solid 3 marks. But our goal isn't just to find the answer. It's to figure out precisely how an examiner awards those 3 marks so we don't leave any on the table. Right, let's dive in. First up, we need to be crystal clear on what the question is actually asking us to do. Here we go, question 12. It says, find an equation of the straight line perpendicular to L that passes through 6, -5, where L is 2y equals 3x minus 7. Okay, so there are 3 golden nuggets of information here. We've got our original line L, we've got the keyword perpendicular, and we've got the exact point our new line has to pass through. Let's get that first mark in the bag. This one is what's known as a method mark, or M1, and it's all about finding the right gradient. So before we even touch a number, we need to remember the rule. For 2 lines to be perpendicular, their gradients have to be negative reciprocals of each other. What does that mean? Simple. You flip the fraction and you change the sign. So if your starting gradient is m, the one you're looking for is -1 over m. Okay, let's put that into action. First, we need the gradient of our starting line, L. Its equation is 2y equals 3x minus 7. To find the gradient, we need it in that familiar y equals mx plus c form. So we've got to divide everything by 2. That gives us y equals 3 over 2, x minus 7 over 2. So our gradient m is 3 over 2. Now for the perpendicular bit, we flip 3 over 2 to get 2 over 3, and then we change the sign. Boom! Our new gradient is -2 over 3. And here is the first secret to cracking the code. The official mark scheme says you get the first method mark, M1, just for showing that the perpendicular gradient is -2/3. You don't even have to show all the rearranging, though. It's really good practice. Just getting to that value gets you on the scoreboard. All right, 1 mark down, 2 to go. We've got the gradients of our new line. The next job is to figure out where it crosses the y-axis. In other words, we need to find the intercept, C. We've actually got everything we need right here. We know our new gradient is -2/3, and we know the line passes through the point 6, -5. That's our x and y value right there. So all we have to do is substitute all of this into our trusty equation, y equals mx plus c, to find that one last missing piece of the puzzle, c. Let's walk through it. We swap y for -5s, m for -2/3, and x for 6. That gives us -5 equals -2/3 times 6 plus c. Now to simplify. -2/3 times 6, well, that's just -12 over 3, which is an easy -4. So now our equation is much simpler. -5 equals -4 plus c. Just add 4 to both sides, and we find that c is equal to -1. And check this out, here's another key insight straight from the mark scheme. You get the second method mark, another M1, just for showing the correct substitution. Seriously. The second you write down that line, putting all the numbers in the right place, you have earned that mark. It doesn't even matter if you make a mistake solving for C later. Okay, we're on the home stretch now. We have our gradient, M, and we have our y-intercept, C. It's time to put it all together and lock in that third and final mark. This final step is usually the easiest part. We just take our gradient, m equals -2/3, and our intercept, c equals -1, and we simply plug them back into the y equals mx plus c format to state the final equation. Now, here's something really important to know. The mark scheme allows for several different answers that are all mathematically the same. That little O sounds for or equivalent. So the most direct answer is y equals -2/3 x minus 1, but you could also rearrange it to get 2x plus 3y plus 3 equals 0. Or you might have used a different formula and ended up with y plus 5 equals -2/3 times x minus 6. All of these are 100% correct. And there you have it. The last mark is an A1, which stands for accuracy. You only get this mark for a totally correct final answer in any of those forms we just looked at. This mark is the reward for getting your previous method right. So let's just do a quick recap of the game plan for a question like this. let's see what we've learned about cracking that exam code.
This table just breaks it down perfectly. Your first mark, M1 for the gradient. Your second mark, another M1, just for the method of substituting to find the intercept. And only the final mark, the A1, is for getting the final equation spot on. See that? 2/3 of the marks are just for showing you know the right steps to take.
And that's really the big lesson here. On a non-calculator paper, laying out your method clearly is everything. Even if you have a bad day and mess up the final bit of arithmetic, showing that you knew how to find the gradient and substitute the point can still get you 2 out of those 3 marks. That's huge. So what do you do with this now? Don't just practice answering exam questions. Practice taking them apart. Here's your challenge. Find a past paper, find the mark scheme, and don't just check if your final answer is right. Look at how the marks are actually given out. That's how you stop leaving easy points behind and really start thinking like an examiner.